So my background is in particle physics, which are characterized by like huge streams of data that we need to be like sort of grokking as they come in. And one of the realities of that situation is that basically we're producing much more data than we can actually write to disk. So in real time, we have to decide whether to write an event or to like throw it away and wait for the next one to come in, because we can take like, you know, a fraction of a percent of our data. So we have to have these like dedicated setup like hardware, software systems that can do like the super like low latency decision making to try to decide whether we're going to write it down or not. We call it a trigger, but that's one of the reasons I'm so excited about this. I was like, oh, it's a trigger for like real stuff, not just particle physics. Yeah, so we use this all the time. This is like our bread and butter.
But do you have any idea how much data that you produce? I mean, in terabytes or in petabytes?
Oh yeah. So we write, we produce 40 million a second. We write 100 a second, and I think each event is tens of megabytes.
Oh wow, that's a lot of data.
Yeah, it's huge amount of data. Yeah. So we're cheating a little bit because we have dedicated hardware and sensor systems that are set up to be just super fast.
But that is to
this,
get
of course,
the
is
data.
much more flexible.
Yeah, with those sensors, sensors are supposed to fetch the data somehow, because it is tapping into all those instruments and all the various things. Once you tap the data, then you run through some kind of real-time pipeline, something like a Storm, or probably you have a dedicated system.
And, I mean, the other thing is that it's a big, complicated thing, and things break. So you also need to be running analytics on the machine, because there's a sensor that might go down, and you need to detect that right away, because it can shut down the whole machine. So that's another sort of side project.
It's like monitoring those sensors itself.
Exactly.
So that's pretty cool.
Yeah.
So anybody else encountered any new real-time systems, or?
Well, we do fraud detection.
Fraud detection?
Fraud detection.
Wow. Okay.
Yeah, so we do see users' behavior online, like in real time, and as soon as somebody is doing something suspicious or not anomalous, we need to stop that from happening. So that's kind of like in the milliseconds domain.
Okay. Yeah, that's super cool. I mean, do you guys take into account some kind of a location information also, or location history also of where people buy things? Right. So if their pattern is beyond that, whatever the history that you have seen, then immediately you have to trigger some things. So do you go to the latency of whether even allowing the credit card to go through, or it's just only for the web-related stuff?
So it's not just necessarily credit cards, but also when you're online, you're trying to wire money out to a different person. That could be stopped, prevented.
Okay.
Sometimes banks gives the user a day or two to clear the money, and that's plenty enough. From our analytic perspective, we
but you
store
can,
it, and then they can use that to decide whether to release a wire or to put it on hold.
Okay. Yeah, that's pretty interesting. Definitely.
Yeah.